In this video, we're going to focus on finding the volume of pyramids, and then we'll look at cones also in just a minute. So our definition of what a pyramid is some 3D shape. It has one base instead of two, because remember when we were working with prisms, they had a base at the top and the bottom of the shape. Pyramids, they just have one base. It's at the bottom of the shape, and all the other faces, all the other sides are made up of triangles meeting at what's called an apex. So right here at the tippy top of all of these pyramids, all of those are called apexes. So that's an apex. Okay, so they all meet at these apexes, and for the base, that's at the very bottom, this base can differ depending on what kind of pyramid you have. So for example, this is a triangular pyramid because it has a triangle for the base, where this one is a rectangular pyramid. So it has a rectangle for the base, or a square, so it has a square for the base. So the formula that we're going to use to solve for the volume is going to look like this. It's actually very similar to the one we were using for prism. The only difference is that we're going to have the number 1/3 in front of this formula, okay? So this B here still means the same thing that it did in the last video. This is the area of the base, okay? So depending on what kind of base we have, whether it's a square, a rectangle, or a triangle, we're finding the area of that first, plugging that in, then seeing how high our pyramid goes, what the height is, and that height can be inside the pyramid, like we see like this, like it goes from the apex all the way down to the bottom of the base, or it could be shown on the outside. So sometimes we might see the height on the outside like this. Either way, we're just trying to see how tall our pyramid is, and that gets plugged in there. So let's go through some examples of how to do this then. So let's find the volume of this pyramid. So I'll go ahead and write down the formula here so we have it to reference. So the volume is 1/3 times B times H. And then let's go ahead and look at our pyramid. So first thing we'll focus on is what kind of base does this have? Okay, what shape is the base? All right, since it's a rectangle, I have to remember what is the formula? What is the formula for the area of a rectangle? Okay, whatever that shape is, I need to know the formula for the area. All right, so if you remember from the last video, for a rectangle or a square, the formula is just length times width, okay? So in for B, because B is my base, I'm going to plug in length times width, okay, because I'm working with a rectangle. And I'll bring everything else down, so I have 1/3 still multiplied in front, and then the height is being multiplied behind it, okay? All right, so all this is telling me is I'm just doing 1/3 times length times width times height. And it looks like I have all three of those numbers there. This would be my length, this is my width, that's my height. I just plug all three of those numbers in, multiply them, and then also multiply that by 1/3. So here we go. So 1/3 times 10 times 3 times 12. So the value that I'm getting from that, once I multiply all three of those together, is 120 inches cubed. So that is the volume of our pyramid. That's how much water it could hold if it was filled up with water. All right, next one. So let's go ahead and write our formula again. So volume is 1/3 times base times the height, the area of the base, exactly. Whoa, so there's a lot going on here. There's a lot of numbers to work with. Well, first thing I'll focus on is what shape I have for my base. So it looks like that's going to be a triangle. So this time I'm thinking, all right, well, I need to know the formula for the area of a triangle. What's the formula for that? Okay, so if you recall from the last video, the formula for the area of a triangle, and that's what I'll be plugging into B. Okay, that is 1/2 times length times width. Okay, 1/2 times length times width. And then I'll bring everything else down in front of this, so I'll multiply this still by 1/3, that's still in the front, and this is still being multiplied by height. But now I'm going to use this formula because I'm working with the triangle for the base. Okay, so let's see here. There's a lot going on. So what I can actually look at here is the length of my triangle would be this 10 millimeters that's right here. Okay, this is telling me how long my triangle is from here to here. And some other words you might hear for this instead might be like base and height. So sometimes I think in the formula that they use in the notes actually, they use base times height. And we can use that if it's a little easier to see it that way. Really, it's just two different letters, but it means the exact same thing. But I don't want you to get confused with this height here. This is a different height because we're just looking at the flat 2D triangle and looking at its height here. So the base of this particular triangle is 10 millimeters, so that's the base there. While the height of this would be from the base, so it has to touch the base, and then it goes all the way up here. So this distance, that would be the height. So that means this 13.077 is our height. And we're actually going to ignore these two values here. We don't care about those. So how do I know this is the base and the height? Well, actually the way that I know that is because they touch perpendicular to each other. They touch each other at a 90-degree angle here, okay? So that's how I can tell that this is the base and that this is the height, okay? They are perpendicular. That's the big trick. All right, so I can plug those in for the base and the height that's here. Actually, let me color code this so we don't get confused. So this is the base and the height that I'm plugging in for those two values. And then the actual height, how tall this pyramid goes up, is going to be, remember, from the apex all the way down to the bottom of the base. So that would be this distance here, which is 11. So that's what I'm going to plug in for the height that's here, okay? So again, this part in red is just talking about our flat 2D shape. So I'm just looking at these numbers that have to do with this flat 2D triangle. And then the actual height of our pyramid is this h that's out here. So we have all of those values. Let's go ahead and plug everything in. So I have 1/3 times 1/2 times 10 times 13.077 times 11. All right, so then I just have to multiply all of those numbers together. That's 13.077 times 11. And again, I highly recommend using Desmos because you can just take all of this, plug it into Desmos at once, and avoid any little computational errors that might occur. So I'm getting 239.745. And depending on your homework assignment, it may say round to the nearest tenth. Let's go ahead and do that for this problem. So that would just round down, so it'll just keep it as 7. So 239.7 millimeters cubed. There we go. All right, so that was a look at when we had rectangles or squares. We would use the same formula if it was a rectangle or a square for a pyramid, or if we had a triangle if we had a triangle for the base, okay? So now what happens if we have a circle for the base? Well, this is actually a completely different shape now because we're working with a circle. This would be a cone, okay, instead of a pyramid. So now this is a cone where the other two shapes were pyramids, okay? And cones are special because they have circles at the bottom. So we're still going to use the same formula. But then because the base that we have is a circle, we need to know the area of a circle formula. And that's what is going to get plugged in for B. Okay, maybe you haven't memorized from the other videos that we've gone through, but if not, the formula for the area of a circle is pi times the radius squared. Okay, I'll bring everything else down. So 1/3 multiplied by that times the height. And then now, let's see what I get to plug into this. Okay, so right away I know that the pi, that changes to 3.14. And then now let's see, what am I going to plug in for r, or the radius? So this 6 centimeters here, it looks like it's talking about the distance from here all the way to here. Okay, it's this entire line. So remember, the radius is half of this diameter, because right now this is a diameter. So I need half of that. That would be the radius. So half of that would be 3. So I'm going to plug in 3 for the radius. Make sure, again, that that is squared. And then I'll multiply that by how tall our cone goes up. So that would be 12. All right, so I have all my values plugged in. Now I just have to multiply all of this. So I get 1/3 times 3.14 times 9 times 12. And that leaves me with 113.04. And if I round to the nearest tenth, this is just going to be 0. I really don't need to write the 0, so I can just have this as 113 centimeters cubed. Okay, and the very last problem we'll look at is now a word problem. Okay, so again, remember when we went through word problems with the last videos where we were looking at prisms and cylinders? Drawing a picture is huge. It just makes everything so much easier if you can draw a picture as you're reading through the problem. Okay, so as soon as I hear something about what shape I'm working with, I'm stopping right there and I'm going to start drawing a picture. Okay, so an ice cream shop is trying to decide which ice cream cones to purchase. Okay, so something with cones is happening. Right there, I'm going to stop. Let's draw a picture of a cone, an ice cream cone, okay? It doesn't have to be anything pretty. And you can feel free to like copy like the shape from one of your homework examples if that's a little bit easier. So that would be just a rough picture of a cone. We have that. Okay. The owners of the shop are trying out many different types of ice cream cones. Okay, so we're going with ice cream cones, and we're going to determine the volume the cone will hold. Okay, so the cone they are trying this time, because they're trying multiple cones, it has a radius of 2.25 centimeters. All right, so let's stop there and then draw that on this cone picture. So it has a radius of 2.25 centimeters. Great. And it is 5 centimeters high. Okay, so that's the height right there. So again, we can decide if we want the height to be here, like, oh gosh, that was horrible. Let's try that again. Okay, so it can be from the center all the way down to the apex, and this is just a cone flipped upside down. But there, that's our height, and we can label that as 5 centimeters. Okay. So we have that cone, that's working. What is the volume of ice cream this cone can hold? Okay, express your answer in terms of pi and round it to the nearest tenth. Okay. All right, so let's do this. So we're going to round to the nearest tenth and specify that. And we're working with a cone, so if you remember the formula for that, it's going to be 1/3 times the base times the height. And in for B, the base, the area of the base, since it is a circle, that's what I have for the base, I'm going to use pi times radius squared, because this is the formula for the area of a circle. Okay. Great, so now that I have all of that working for me, I know I'm working with a circle, so I have the area of a circle formula that's plugged in here. Change this to 3.14, multiply this by the radius, so perfect, I have the radius, they talked about that, times the radius, make sure that is squared, and that's 2.25 squared, times the height, which is 5. Nice, so that wasn't too bad. I had a picture and I just plugged in the numbers that worked, and for the radius and for the height, changed that to 3.14, and I just have to make sure I can multiply all of that together correctly. 3.14 times 2.25 squared multiplied by 5. Okay, and I'm getting 26 point, and there's a bunch of numbers that come after it, but when I round it, it should be 26.5, and then let's see, centimeters cubed.